Hello my dear students, welcome back. It's so good to see you at the board. Welcome. What a joy to see you. How was the Matric 3 virtual classroom? Good, you learned a lot from there. Well, let's continue at the board and talk about solid geometry, okay? So we're going to talk about some of the figures. So the type of figures that we're going to talk about is, let's start with a cube. This is called a cube. Why is it cube? Because all the sides are same. Now cube, now look at that. If I have to put perfectly to the surface like this, what kind of shape does it has? A square. How about here? 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 Square. See that? All around is square. And we know that square has all equal length. The same thing with the cube. Also, all the sides are equal length. So it's very important to understand. Okay? For cube, all the sides are equal length. Alright? So make sure you know the term cube. Alright? The next one we're going to talk about is called cuboid. Now the cuboid is a stretch of the cube. See that? Or not necessarily could be stretch, okay? Now for cuboid is a stretch of the cube. See that? Like say for example, look at that. If Mr. Mac to stretch this, become a cuboid, alright? Now the characteristic about cuboid is, if I had to put flat like this, what shape does it has? A rectangle. Now what is the rectangle's characteristic? The opposite sides are equal. See that? So with the cuboid, all the way around, they are equal length, and then all the way this way are equal length. Alright? So keep in mind, but they're not all equal length. Only cube has all the equal length. Cuboid doesn't. Okay? So it all equal this way, and then all equal that way. Alright? Now not necessarily all the time you'll have a cuboid the corners to be square. It could be also a rectangle. In this case, happen to be a square corners. Alright? So cuboid can have different shape as long they are in a form of like rectangle and a square combined to it to the surface, okay? Or you can be all rectangle combined, alright? So the biggest thing is you can understand it's a 3D figure, okay? It's just like a 3D figure right there. When we talk about square and rectangle, those are 2D. So this is 3D, okay? Kind of like we watch the 3D movie, alright? We will wear the glasses, everything comes out to you, okay? Alright, okay, good. The next figure we want to talk about is cylinder. Look at that. This is a cylinder, alright? Now, it has a circle on the bottom, alright? So this is what called cylinder, alright? This is a cylinder, and then next one we're going to talk about is the ice cone, alright? Kind of like ice cone. Oh man, when Mr. Mac was young, I love ice cone. When I hear that the ice cream man ring the bell, we all run out to the ice cream man and it's like, give me a cone, alright? And this is what we call cone. See that? So that's why it comes ice cream cone, alright? So this is what cone, alright? This is a cone, and then I got a sphere. What is sphere? A circle, a ball. And now remember, circle is a 2D. A sphere is a 3D. See that? It's a circle, it's a ball. Alright? It's a ball. See that? Okay, that's a sphere. And then Mr. Mac don't have a shape of a pyramid to show you. A pyramid has the shape of a pyramid. Kind of like you see. Okay, I want to see this picture right there. Alright, that is the pyramid, okay? So keep in mind that's the shape of the pyramid. So right, let's review back again. What do you call this one? A sphere, alright? Let's write that down, okay? So let's put in order. Okay, let's start with a cube. Cube, and then we got cuboid, and then what's the next one was? Very good. Alright, so cube, cuboid, and then we talked about cone, and then cylinder, and then sphere, okay? Very good, alright. And then pyramid, okay? Good. So, and you notice that the pyramid has a, like this, okay? Like a, like that, pyramid, okay? And then of course sphere is a circle, alright? And then it's a 3D, alright, the 3D, okay, and cylinder has a circle on the bottom and the top, okay, and that's a cylinder right there, and then of course the cone, circle on the bottom, and then cuboid, and then cube, okay, alright, good. Right there, alright? So I want you to make sure know how to draw them as well. Okay, we'll talk about how to draw cube and cuboid, alright? So let's look at some of the day-to-day thing that has those figures that we were talking about. Mr. Mac gathered a few items, alright? Let's look at this. Look at that, all these items Mr. Mac got here. What shape is this? Oh, it's a cube, see that? Alright, it's a cube. What shape is this one? A cuboid. Look at that, a cuboid. See that? See in this one, look at that. This one doesn't have a square in the edge. Alright? So it's a rectangle. So not necessarily all cuboid has a square. You can also have a rectangle on the edge. Okay? So another example is this one right here. This is also a cuboid. See that? See, has a rectangle on the edge. Okay? So see that this is a cuboid. Okay? And then now let's look at some cylinders. Look at the cylinders. It's a medicine bottle, alright? It's a cylinder shape, okay? Alright, and another one is Mr. Mac's tea. Mr. Mac loves jasmine tea. See that? Has a cylinder shape to it, okay? See that? So something that you see that very often around now. So now on, when you go to the supermarket or you go to mom's kitchen and look around, oh, mom, that's a cylinder shape. Mom, that's a cone shape. Mom, that's a rectangle. I mean, a cuboid. That's a cube. See that? Okay, and then let's look at a cone. Look at that. I want a light as a cone shape to it. Okay, let's see if I can push it. See that? Alright, that's a cone. And of course the ice cream cone, alright? And then pyramid, just like the pyramid in Egypt. Those are the pyramid shape to it. Alright? Okay, good. Okay, boys and girls. Okay, my dear students, let Mr. Mac prepare the board and we'll learn how to draw cube and cuboid. Okay? And I'll be back with you in a few seconds. Alright, my dear students, let's talk about how to draw cube and cuboid, okay? Now, let's say for example, let's start with cube. So, cube. And what is the characteristic of a cube? And the surface is a square, alright? What you want to do is to draw a cube, you put the first square, and then put a second square, and then join the line. See that? Right there. Now, usually, the hidden lines are broken lines. So what you want to do is just erase them. See that? So this way they kind of show like a broken line. So now you can tell that's in the background. It's kind of given a broken line, kind of because those are hidden lines. See that? Okay. So now how about cuboid? Now for cuboid you can do same idea. This time when you put either square or rectangle, make sure the same shape, move it further. Move it further. Okay? Move it further and then join the top and top and then bottom and bottom. See that? Right there. And that's cuboid. Okay? So pretty straightforward, isn't it? Alright? Okay, keep in mind, to draw a cube, you draw two square, but estimate such a way that this will give you the shape of a square as well. Alright? Because you know that this is going to be square, this is going to be square, that's going to be square, square, square. So you want to make it an estimate how far I should go to create a nice looking a cube. Alright? For cuboid, you want to create rectangles, so you want to further the edges. Alright? So such a way that it kind of stretched. Alright? Now this is kind of a rough sketch. Again, this is at a hidden line, so you want to put a broken line. Take it after you draw it with a pencil, and then you want to take a eraser and then erase the in between, so it will look like a broken line. So in other words, pretty much will look like this. See that? So this is a cube. Now for cuboid, okay? See that? For the cuboid. Alright? So kind of like that. Alright? Now this is kind of like a rough sketch. If you to have a graph, this is a rough sketch. If you have a graph paper which has all these lines like this, so it'll be a lot easier. Then you'll have a nice you can draw a nice figure of a cube and cuboid. Okay, let's say for example, Mr. Max is going to draw a lot of lines here. Okay, and then create sort of like how a graph paper would look like. All right. Okay. I'm going to put a lot of small cubes in there. Okay. Alright, there we go. Okay, good. Alright, so let's draw a cube. So what we want to do is, to draw a cube, you want 1, 2, 3, 1, 2, 3. See that? So this is 1 right there. Okay. See that? That 1, 2, 3, 1, 2, 3. That makes a square. Alright? So now, find another square right here. 1, 2, 3, 1, 2, 3. See that? Okay. Now 1, 2, 3, 1, 2, 3. So we're going to make another square right here. Okay. Then I'm going to join it. See that? That create a cube. Okay. Let me darken it so you can see it better. See that? So 1, 2, 3, 1, 2, 3. So that makes one square. 1, 2, 3, 1, 2, 3. That makes another square right there. And then once you drew this two square and then join them from the edge to edge. See that? Once you join them, now look at that. It turns out to be a cube. Okay? And you do the same thing with the rectangle. Alright? So in this case, I want to count, let's say for example, 1, 2, 3, 4. And then 1, 2, 3. Okay? So I'm going to create a square. Okay? Square edges. So let's darken it. Alright, 1, 2, 3, 4, 1, 2, 3, or you can do 1, 2, 3, 1, 2, 3 and use a square. Okay, so square edges also as well. Okay, not necessary. Then now I want to move this up to here. Okay, so I'm going to put 1, 2, 3 right there, and then 1, 2, 3, 4 right there, and then I'm just going to darken that. Once I draw two rectangle or square, now I'm going to join the edges. Look at that. Once I join the edges, we want it to turn out to be a cuboid. See that? Pretty easy, isn't it? Okay, the key thing is square and square. But keep it closer and make an estimate such a way that, because when the 3D, when you look in the corner, there's no way you can tell how long you want to create that. Okay? So you make an estimate such a way that, you know, because you don't go too far and don't want to go too small, because it loses the cube, okay, the characteristic of a cube look. Alright? But with the cuboid, it's pretty easy. You just stretch it as long as you can, and once it's long enough, it will become a cuboid. Alright? Now cube, you got to make an estimate. That's why your creative mind comes in and figure out, okay, let's say for example, Mr. Mac to draw a cuboid right here, another one, like let's say, let's put more line here. Let's put more line here. Okay, I want to put let's put more right there. Okay, let's say I want to draw one right there. 1, 2, 1, 2, a smaller cube. Okay, let's say if I put too far out, look at what happened. It looked like a cuboid. See that? When I went too far out, see that looked like a cuboid. Am I right? So I want to keep it closer. How about if I pick right here? If I pick right here, and then erase that. So that gives a cube shape. See that? See that? See the difference by moving it one up and one down? See that? Makes a big difference, alright? So that's how you make the estimate, you gesture, okay? You guess, alright. Look like, oh, that's too far. It look like a cuboid. So bring it closer. Now it looks like a cube. Okay, good. So you knew how to draw using graph with a graph paper. Okay, so you draw two square and then join the edges. Estimate how far you want to keep this square apart. All right. Now with the rectangle, with a cuboid, so you can stretch it out and then you can draw the line on the edges. Okay, I mean connecting the edges. Very important. All right. All right. Good. Well, okay, good. Okay, so very important. Now, let's do this. Let's cut them apart and find out how many surfaces does cube and cuboid has. Alright? Give me a few seconds. Let Mr. Mike erase the board and we will desegment the cube and cuboid and find out how many surfaces they have, and I'll be back within a few seconds. Alright, my dear students, now let's cut a cube and cuboid and find out how many surfaces they have. Alright, so first thing, let's say this is the cube. Alright, we're going to do is cut this onto the corners and open it and see how many surfaces. Okay, Mr. Mac kind of did this. I created a cover for the cube. Look this right here, a cube. See that? All covered up. Alright, and then I'm going to take this blade right here. Alright, now be careful. Alright, okay, they're pretty sharp. So I'm just going to cut them and find out how many surfaces comes to. Okay, so when I cut it, one surface from the top, another surface from the side, another surface from the side, and then a surface right there, and a surface from the bottom, and then a surface from here. See that? See, can you see that? Okay, this is the back, this is to the side, this is to the top, and this is for the bottom, and this is to this side. Okay, if I had to open them up after I cut them, look at that. How many surfaces form a T? Okay, so 1, 2, 3, 4, 5, 6. So a cube has 6 equal square surfaces. Alright, okay, so let's mark them. Okay, let's take a marker here and then we'll put down. Alright, so we got 6. So 1, 2, 3, 4, 5, and 6 square surfaces on a cube. Alright, very important. Alright, this is a 1 square right here, and there's another square right there, and there's another square, and another square, another square, and another square. Alright, so there are 6 total squares in a cube, and all of them are equal. Square, 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 they all are equal for a cube. Very important. Alright, you can understand there are 6 of them. Now let's take a cuboid. Alright, now we're going to do the same thing with the cuboid. Okay, we're going to take this knife here, okay, this blade, and then we're going to cut them at the edges. Alright, and then we're going to open the surface, and then so Mr. Mac did the same thing. I created a cover for that. Now look at this, it's all covered. Am I right? So now we're going to open up. So let's open them up. Okay, I already cut it. So this is the top surface. Alright, so this is the top surface, and this is a side surface, and this surface right there, and then there's a bottom right there, the bottom surface. Okay, now look at that, also forms a T shape. How many surfaces are there for a cuboid? 1, 2, 3, 4, 5, 6. Also 6 surfaces, but there's a bit different than a cube. Now let's mark them. 1, 2, 3, 4, 5, and 6. But look at this. 1 rectangle, 2 rectangle, 3 rectangle, 4 rectangle, and all these 4 are identical rectangles. On the edges, they are identical. It could be the square or rectangle. Okay, so these 2 are going to be same, and these 4 are going to be same. Now let's take this cube. Look at the difference between the cube and a rectangle. A cube and a cuboid. Now look at the difference between the cuboid and a cube. Now they both have 6 surfaces. For cube, all 6 of them are equal surfaces. That means they are square, 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 square. Now for cuboid, 1, 2, 3, 4 rectangles are identical, and then the edges depend on the shape. Right, now look at this. For cube we got 1, 2, 3, 4, 5, 6. All these are equal square. Now for cuboid, 1, 2, 3, 4, all around it, okay, are equal size, which will be rectangles. Alright, now the edges, the 2 sides of the edges of the cuboid, always either square or rectangle, but they will never be same to this. They both are always same, these 2, but never same to this. But these 4 are always same. Keep in mind. Alright, in a cuboid you cannot have equal surfaces all the way around. Alright, only the 4 and the 2. Alright, 4 will be equal, and then the other 2 edges going to be equal to each other. Alright, so it's very important, you got to understand that. Now, is it all the time all these four is going to be equal? Not necessarily. Depend on the shape. In this case, it turned out to be, because these two are square, and that's why all these four are same. If they're square, if this is rectangle, the opposite sides are going to be identical. What do I mean by that? This two is going to be opposite to each other. Okay, so in other words, if I look at it like this, see that? This surface and this surface, so this surface and this one are opposite. They're going to be identical. And this surface and this surface are going to be identical if this is not a square. If it's a square, all the four of this are going to be identical. Only if this is square. If this is a rectangle, keep in mind, if this is a rectangle, the opposite, what I mean by that, opposite surface, this surface is opposite to the bottom, the top opposite to the bottom, this side opposite to the back. See that? The back, okay? They're going to be identical. This is going to be identical, and the top and the bottom is going to be identical if this edges are rectangle. If it's square, all four of them are going to be identical. Alright? Keep in mind. Okay, good. So the key thing is, for cuboid, you will never have all equal surfaces, alright? Only either 4 or vice versa, alright? 4, if it's a square, 4 will be equal, and then the 2 square will be equal. If it's a rectangle, this 2 will be equal, and then the opposite of the surfaces will be equal. Okay, so in other words, this 1 and 3 will be equal, 2 and 4 will be equal if these are rectangles. Alright? Okay, good. Alright, Mr. Mac, what I did is, remember earlier Mr. Mac kind of showed you. Alright, let Mr. Mac bring these boxes that I was showing you earlier. Okay, let's take the first box. Okay, this is the ointment box. Look at that. What shape is this ointment box? It's a cube. Alright, what Mr. Mac did is I cut this box out so that you can see how the shape looks like, the surface shape. Alright, so look at that. And how many surfaces are there? 1, 2, 3, 4, 5, 6. Now when it's a cube and each surface makes what? A square. Alright, that's a 6 squares. Alright, now let's say when you go to university and you want to study to be an engineer, a packaging engineer, right? And you become a packaging engineer for a company after you graduate from your university. You need to know how to design boxes or packages for products that the company is manufacturing. Alright, in this case, let's say for this ointment right here, you need to design the box such that it fits it right. That's just very important to understand on the solid geometry. Okay, alright, now see that? So how nicely it's been designed such a way that this medicine bottle can fit in right into the box. Okay, so again, that's why you need to understand how cube and cuboid surfaces works. Alright, so again, this is what? Cube. And how many surfaces are there? 6. And what kind of surfaces each of them are? What kind of surfaces each of them are? Square, right? Square. Now let's look at the cuboid example of a box. Okay, so now earlier Mr. Mac has showed you this noni, okay, noni box. Okay, now this is a supplement that Mr. Mac take every day. Noni juice is very good for you. Mr. Mac take that every morning. I take a drop and drop underneath Mr. Mac's tongue. Okay, that's how best way that thing absorb into Mr. Mac's body. Okay. And what Mr. Mac did is, I cut this box out. Now look at when I cut this box out, and you can see the products in there. See that? You see the bottle, the manual, and then the suction device that takes that liquid, the juice, the noni juice, so I can put drops in it. Okay, so let's put this aside. Okay, let's put this on the side, and then let's look at this box. It's a cuboid. When I cut it open, how many surfaces are there? 1, 2, 3, 4, 5, 6. Now remember earlier we talked about if the edges or the top and the bottom, if it's a square, what happened to all the surfaces? Will be identical rectangles, alright? Identical rectangles for cuboid. Now if this case, the top and the bottom is what? It's not square, it's what? It's rectangle. So if it's a rectangle, what's going to happen? Okay, now that means the opposite sides are going to be identical. So this and this is going to be identical. This and this is going to be identical. Now they all are rectangles. It's just that they're not identical, all of them. It's just the opposite rectangle is going to be identical. So if I to Mr. Mac bring the cuboid again, when I say opposite, if this is the top and this is the bottom, they are opposite to each other. This is the front side and this is the back side. They both are identical. This is the edges, the opposite sides are identical. Alright? So keep in mind. In this case, this one is a square. That means all around it are going to be identical rectangles. Okay, the top and the bottom, it's going to be identical, and also identical to the sides. Okay, from the front and the back. Okay, keep in mind. So let's recap again. If it's a rectangle edges, the opposite's going to be identical. They're not going to be all same, alright? Like the way the square was, alright? Good. Well, I'm so proud of you. I'm so happy that you learned so much on solid geometry, okay, on the shapes, alright, especially the surfaces and also how to draw them on this sub lesson. Okay, so let's go to sub lesson. Next sub lesson we're going to learn about the volume. Now there is no quiz or hands-on practice on this sub lesson. This is more informational. It's just you want to learn, you want to understand what is solid geometry is all about. Okay, good. So let's give yourself a break, take a break, nice break, and then come and see Mr. Mac on the next sub lesson, and we're going to talk about volume, how to find volume for cube and cuboids. Alright, and I'll see you soon. Bye bye.